Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
To answer a couple of questions related to an astronaut which is connected to a helicopter. Let's first sketch the system for the simplicity. So this is a helicopter, and we are going to show an astronaut as a material point because its size is much lower in comparison to the size of the helicopter. So this is initial position of the astronaut, and it's connected to a helicopter with a rope. So now let's introduce the coordinate axis y. So here the coordinate of the helicopter is h, and coordinate of the astronaut is 0. So for the simplicity, we'll also label them as y0 and y final respectively. So the astronaut experiences a gravity force which pulls the astronaut down, and the force generated by a helicopter which lifts the astronaut up. And overall it results in acceleration of A which is directed upwards. So now let's write down the second Newton's law for the movement of the astronaut. So the vector sum of force generated by a helicopter and gravity results by m multiplied by acceleration of the astronaut. Or if we project it on y-axis, then f helicopter minus mg equals to ma. So therefore, force generated by a helicopter equals to mass of the astronaut multiplied by the sum of g and a, or it equals to 1.1 mg. So now we can answer the first question, where we have to calculate work done by a helicopter. So the work done by a helicopter equals to the force applied by a helicopter multiplied by the displacement of the astronaut, which is y final minus y0, or force generated by a helicopter multiplied by h, because y final equals to h and y0 equals to 0. Or in other words, it equals to 1.1 mgh. So now we can calculate work done by a helicopter. It equals to 1.1 multiplied by 9.8 multiplied by 75 kilograms and multiplied by 15 meters. So let's use a calculator to get the final result. Just a small correction. Mass of the astronaut is 72, not 71 kilograms. Sorry, not 75. So let's calculate it again. So it equals to 11,624 joules, or 12 kilojoules if we round it up to 2 decimals as we need, because 2 decimals are contained by the mass and by the displacement. So now we can answer the next question, which is work done by the gravity. So the work done by the gravity equals to the gravity force multiplied by the displacement. And here I have to point out that in general work is a scalar multiplication. Therefore, if direction of force is opposite to the direction of the displacement, the work is negative. So therefore, in this specific case, the astronaut was moving upwards, but the force is directed downwards. So therefore, work done by the gravity is negative. So it's negative mg multiplied by h, or it equals to negative negative 72 kilograms multiplied by 9.8 meters second squared multiplied by 15 meters. So let's calculate this number. So it equals to negative 10,584 joules, or roughly minus 11 kilojoules. So this is answer to question B. And now we can answer questions C and D. So in question C, we have to calculate kinetic energy when the astronaut reaches the helicopter, and in question D, we'll need to calculate velocity of the astronaut when it reaches a helicopter. So, and for the simplicity, we'll start with question D. So as we know, displacement of the astronaut equals to her final velocity squared minus her initial velocity squared divided by 2 accelerations. So therefore, the initial velocity is 0. Therefore, final velocity of the astronaut equals to the square root of 2ah, or square root of 0.2 gh. So now we can calculate this number. It's square root of 0.2 multiplied by 9.8 meters per second squared multiplied by 15 meters. So let's use a calculator to get this number. It equals to 5.4 meters per second. So this is an answer to question D, and now we can come back and answer question C. So kinetic energy equals to the mass of the astronaut multiplied by squared final velocity divided by 2. Or in this case, it's going to be 72 kilograms divided by 2 and multiplied by 0.2 gh. So let's complete this calculation. So it equals to 1058 joules, which roughly equals to 1.1 kilojoule. So here is a solution of this problem. I hope I helped you. Thank you very much for your attention.